Hi, I'm Owen and I will be doing page 76, number 27. A tennis player standing 12.6 meters from the net hits the ball at 3 degrees above the horizontal. To clear the net, the ball must rise at least 0.330 meters. If the ball just clears the net at the apex of its trajectory, how fast was the ball moving when it left the racket? For this problem, I will make up positive and to the right positive. In the diagram and in the blue box, we can see the tennis player hitting the ball at an angle of 3 degrees above the horizontal. Since the ball just clears the net at the apex of its trajectory, its maximum displacement in the y-axis is 0.330 meters. The diagram also shows a mock trajectory of the ball and the distance from the player to the net. From the problem, we are given the two displacements, 12.6 meters in the x and 0.330 meters in the y. Since up is positive, the acceleration due to gravity is negative 9.8 meters per second squared. There is no acceleration in the x-axis, making it 0 meters per second squared. The velocity in the y direction at the apex of the ball's trajectory is 0 meters per second. All of this is shown in the chart. The triangle shown is a representation of the trajectory of the ball as it's hit 3 degrees above the horizontal. The variable c indicates the final velocity that we want to solve for. Since we are given enough information to solve for the initial velocity y component, we can solve for the y initial velocity and use that along with the angle measure to solve for the actual final velocity. To solve for the initial y velocity, I will use the vf squared equals vi squared plus 2a delta x kinematic. After manipulating the variables and plugging in what we know, the initial velocity in the y comes out to be 2.54 meters per second. Since this is the y component, if we take the sine of 3 degrees, we can solve for the actual final velocity. So we do the sine of 3 degrees equals opposite over hypotenuse, or 2.54 meters per second over c. After manipulating and solving, we get 48.53 meters per second. So the initial velocity of the ball is 48.53 meters per second.